Hi there. In this video, we're going to be talking about the energy of a system. So again, we want to revisit this idea of a system that we talked about in Chapter 7. A system is any sort of almost arbitrary grouping of objects that we're interested in. So we said back in Chapter 7 that we're going to have two objects or something that with forces in between them, and that was going to be our system. Everything else was going to be the environment. In this scenario, we don't really care so much about the forces in something as much as we do as just the arbitrary kind of grouping of these objects. So we have our system, right, which is just, saying I have object 1, 2, 3, one system. Everything else is going to be the environment. And I want to talk now about the energy of that system. So we probably need a definition at this point. Energy is the measurement of a system's movement, or maybe to also include potential energy, the potential for movement. When you boil it down to it, that is what energy is. Even in cases like thermal energy, we're talking about randomized movement, vibrational movement of molecules internally, right? Potential energy is stored interaction energy, right? There's some sort of interaction between things in our system or things with our system and the environment, and we're storing energy. We're storing that ability to move. And kinetic energy is just kinetic. It's the movement energy, right? So we have kind of three easy ones to talk about: kinetic, potential, thermal. We're not really going to talk about thermal too much. We're going to push that off if you have a dedicated thermo class to that. I wish we had more time. There's some really interesting things with statistical mechanics and thermodynamics that we can talk about. But at the end of the day, it really is this idea of a measurement of a system's movement or the potential for movement. Now, it's not just movement itself. We already have a measurement for that. It's called velocity, right? So it needs to include something else, and we're usually going to involve the system's mass in a certain way. When we have a system here, we can talk about energy between objects in our system. We can talk about the system itself having different types of energy: kinetic, potential, thermal. And the system can transform energy into these different types without any loss. Now, realistically, that's a little far-fetched. It's not far-fetched, it's just unrealistic, right? There's usually loss in a system, right? There's usually some sort of internal friction or something that is going to, as we'll find out later in this chapter, sap energy from our system and put it into the environment. So it's a slightly unrealistic scenario. It's a very simplified model, let me put it that way. But again, we're building these simple models to make more, to build more and more on top of those, and then complicate them further and further until we have a much more realistic view of the world. So this is the backbone for our conservation of energy. And actually, it's a law. We can even write that, the law of conservation of energy. The law of conservation of energy is that energy cannot be created or destroyed, simply transformed from one type to another. For us in this scenario, we're going to say that the change in energy in a system is always going to be zero unless there's work done by an outside environmental force. So for this system, we can change things from kinetic to potential to elastic potential or gravitational potential back to kinetic without any sort of loss. We're thinking about ideal springs, ideal situations. And that allows us to say the change in the system's energy is equal to zero unless, and that's going to be what the next video is all about. So, law of conservation of energy. Energy is not created nor destroyed, simply transformed, even when we're talking about from the energy of an environment, the energy of a system. So we're going to talk about work next time. Thank you guys. See you in a bit.